Hi, everyone. Welcome back. I've decided to post a lecture on this for you all's reference to walk through. I do not think we'll have class today, but you'll see an announcement from me shortly on that. So really the whole purpose of today is to look at, well, first off, look at my microphone. And secondly, look at just kind of the initial building blocks of Python. And what are we doing? Just the really initial things. We'll go over all this on Wednesday during the lab session as well. But let's run through the slides real quick and talk about some of the things that we're going to see on the slides. So you'll see this is this week, obviously, background. Okay, so when we talk about Python and we talk about programming, really what we're trying to do is to develop our problem solving skills, right? Problem solving is the ability to, one, identify problems, to think creatively about solutions, right? To consider and account for different biases, different assumptions, or different ways of doing things, and then to express a solution clearly and accurately. So when we think about this in terms of Python, you really need to, we're going to be using this in data science. So we're interested in identifying data-related problems. We need to think creatively about how to build code to address those problems, right? The code isn't going to magically appear. We have to think creatively about how best to handle that. We need to account for our assumptions and biases, just like any data science project. But in this case, in Python, we need to make sure that we are sampling correctly, we're doing other things correctly, and then we need to express and clearly and accurately convey our findings. And we're going to do this in Python through data visualizations, through charts, etc. Okay, so what is a program? Right? A program is simply a sequence of instructions that specifies how to perform a computation or how to perform some sort of action. Okay, that's all a program is. Okay, so when you turn on your computer and you start up a video game, it is a series of instructions that tells the computer what to do, what to show, what sort of things to bring up, just like Excel, right? Excel is instructions to your computer on what programs to load, what to do, how to do things, when there are errors, etc., right? So every program has input, right? It takes in information. It gets information from a keyboard, from a file, from a network, from other external sources, external sensors, from other things, and takes in that information and then displays an output, right? It does something. So like, let's say you are playing in Excel, right? You're developing a budget in Excel. You are putting in numbers via your keyboard, right? And Excel is interpreting those and doing calculations on those, and the output is what you see on the screen. Okay? Just like in a video game, right? You are moving the mouse or hitting the keyboard, and you are giving instructions to that program, and that program is doing things and displaying different outputs from your actions on the screen. Okay? So a program is also going to do math. All programs are going to do some sort of arithmetic or mathematical operations. Video games, Excel, Word, it's all doing some sort of math underneath it, right? So our programs are going to have, we're going to give them input, they're going to have outputs that we're going to see, they're going to do mathematical functions, and we're also going to build in conditional execution. Right, we want our programs, and these are data programs, right? We're not building video games. We're building algorithms to do analysis, right? They're going to have some sort of checks for conditions that are going to run when appropriate. Okay, so let's say I only want my program to run if I have 10 responses to my survey. Okay, that's a conditional execution, right? It's not going to run until I have 10 different things identified from my survey. And then repetition. There we go. We want this to repeat itself. We want it to be able to do it over and over and over again, right? If it was just run 2 plus 3, we wouldn't want to need a program for that, right? You could do that once, right? But if it was add 2 to every single number that we know of, you're not going to want to do that by hand, right? We want this to be able to repeat and run independently, so that saves us time and effort. All right, programming. So we know program is all the things I just described, has inputs, outputs, conditional execution, has math, has repetition. What is programming? Program is the process of breaking a large complex task into smaller components. Okay? What we're after is to take each individual step and give it specific instructions so they can move on to the next one, right? So let's say on my example of adding up every single number, add 2 to every single number that exists, right? My first block will be 1 plus 2. My second block might be 2 plus 2, 2 plus 3, 2 plus 4, etc., 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 right? Or, on my example of the surveys, right? My program might be to analyze all survey results from JMU students. I can't just say, computer, analyze all the survey results, right? Because then we're talking about 20 or 25,000 students, right? It doesn't work. It's too big, right? But instead I might say, okay, well, first I need you to sort out this group. Then I need you to sort out this group. And then I need you to randomize a different column. Then I need you to do these things. I need you to do these things, right? So there's different elements that need to be done, different instructions that you need to do, and that is what a program is, right? We're giving it a basic instructions, right? Programming language are like formal language to express computations. Like I said last class, programming languages are foreign languages, right? They have rules, they have syntax, they have different ways, different norms of how to do things, right? You're not supposed to end a sentence in a preposition. You can, but you're not supposed to. Just like in Python programming, you can do certain things, but you really shouldn't. And we'll talk about that as the semester goes on. So have strict syntax rules, have different ways of dealing with bugs and errors. We'll talk about debugging and whatnot later in the semester. It's not going to be that big of a problem up front. And frankly, it's not going to be that big of a problem for us in general, right? Debugging comes when we're trying to run a program that is more action-oriented rather than analytically oriented. And we can talk about the differences later. So think about a computer as an employee with certain strengths like speed and precision, particular weaknesses like empathy and ability to grasp the big picture. So we are going to program with the idea that we want to do large mathematical analysis as quickly as possible. Okay? And so that is what we're after. So why Python? Python's great. It's super easy. And by easy, I mean it has its nuances, but it is fairly easy to learn compared to other ones. It's straightforward, right? Print hello world is much easier in Python than in Southern languages where you have to get into several different lines of code to print something onto the screen, right? So it's incredibly efficient. There are lots of libraries and resources. GitHub, Stack Overflow. Well, I think I have some links here in a little while. There's a lot, right? It is widely used in data analysis and machine learning. So if you go to one of the job sites and search for Python, you're going to find a lot of results, right? There's a lot of demand and a lot of need for the language out there. It's also a large community, right? So there's a lot of people working in Python that you can actually engage with and help you, right? So what is the hardest part about programming, right? This hardest part is going to be the next few weeks, okay? It is a new language. It's going to be, the hardest part is going to be thinking in Python's language, right? Thinking in this step-by-step way that you can't assume that the computer is going to do something that you want it to do. You have to, almost like a detective, figure out the best way to do things. And trial and error, right? We're going to make a lot of mistakes. You will see me make a lot of coding mistakes in class, but it is a new opportunity to learn something about Python, a new learning way to learn something about problem solving. And okay, it's okay to make mistakes. It's great when you make mistakes because you'll learn from them. When an error occurs in your programming, Python interpreter does the best to help figure out where the problem is. The previous platformer we used was great because it would underline certain errors. This new one is going to tell you what line the errors are on generally, and that's helpful, right? So you don't have to look through hundreds of lines of code to figure out what the problem is. It should show you right off the bat what the problem is. Okay. Getting help. This is in terms of documentation. I highly recommend Python's official documentation. I will post a lot of resources I have already on Canvas. I have another one coming today, which I'll put on there that relates to something I'll talk about later. And you don't need to learn everything, right? You're interested in the basics and the fundamentals, and then being able to understand code that exists and apply it to problems that you have. Okay, so let's talk about some of the four, kind of just getting our feet wet, four elemental concepts, right? First is comments. Okay, comments are not executed in the code, right? You can think of them as if you have a book, you writing in the margins of the book, right? They're there, but they're not part of the book, right? And so they'll be skipped in any sort of code that is done or executed. They are only there for you to read or to add notes or to describe what you're doing. Okay, so let's take a look at some comments. Here I've started Google Colab. You can see it asked me to open a notebook. I'm going to say, give me a new notebook. It is eventually going to do that. I'm going to try zooming in to make it a little bit easier for you all to see. And we can start coding. We have our first block of code here, and we want to make a comment. So we can say this is a block of code. You'll notice it is coming out green, right? And I can do print hello students, right? And here I am printing, okay? So when I run this, you'll notice that after this has connected to a server, eventually it will, I promise. There you go. And you can see that the output is hello students, right? It did not print out this code. It is just a block of text, right? And so we can also do this by inserting multiple quotation marks like that. And then we can write along a multi-comment line. So we can say, IA 241, this class is programming. Way to go, IA students. Okay, and then we close it off at the end like that. And we can put in our print so that we have something to show when we run it. We can print. And all we have is this. Okay, and so if you're documenting the work that you're doing, you're going to need this, right? These types of things will help us document our code. Okay, so these are, again, comments are things that we can annotate either using the hashtag or multi-line is going to be 3 quotation marks. But so what the common convention is that if I write some code, I'm going to say something like, instead of this, it's going to say, this next step is meant to print hello students. Okay? Or I can add it here, right? I could do the same thing here. Printing hello students. Okay? Okay, so next we want to talk about two different kind of categories of data, right? We have values and we have types. And so we kind of touch, this relates to what we talked about last semester, right? Value is one of the basic units of data. It is like a number of or string that we can manipulate. Basically, if we look at the code that I had up previously, it would be the hello world, right? That is a value, right? If I put in a bunch of numbers like 1,200,000, right? That is a value. If I put in a string that says hello IA students, that is a value, right? The program can, in Python, we can manipulate those things, right? Type is what category that value falls into. And there are lots of different types. The big ones are integers, right? And you can see that the type there is int. Floating point numbers or floats, those are decimal points. Those types are floats, you can see that. And strings, these are our values that have letters rather than numbers, or a combination actually can have that. But they are not solely integers or floating numbers. Okay, and those are types str. And you can use the type function. Functions are different tools that we can use in Python to kind of quickly get information back. We can use the type function to check the different data types in Python. So before I show you any more code, let's just run through some more of the slides here. Let's look at the two kind of the basic data types. We have text and numbers. Those are our first list. This list is going to expand. We'll include Boolean data types, other things on here. But to start, we have string, integers, and floats. Okay, what is a string? A string is simply a series of characters, right? We declare this by using either a single or double quotation mark. String can include numbers, letters, symbols, combinations of, we can include apostrophes into that. So if we have quotation marks around the string indicating Tom's cat, we can include an apostrophe in there and it recognizes that. So that's not a problem. The big thing here is how this data is treated. It is generally treated as its own thing, right? With values, it's a data container, which we'll talk about in a second, where we have the value of what's in there is each individual component. So for instance, Tom's cat would have, Tom's cat is the value, but each individual component can be manipulated and treated differently, right? So T is a T, O is an O, M apostrophe S, each individual thing we can reference and look at. We can't do arithmetic on it, right? We can't do mathematical functions, right? If I do 2 times Tom's cat, it's not going to be whatever, if we multiply 2 times T, I don't know how we even would do that. What it would do is would duplicate it, right? We'd have 2 Tom's cat, right? We'd have Tom's cat printed twice. Or if we said, 2, or say Tom's cat plus Tom's cat, we'd have the words Tom's cat twice together. Okay, and we'll go through some more examples of these. I know this is on the homework as well. Okay, so the strings, numbers, letters, symbols, all included bits in quotation marks. We can include string methods, right? A method is an action that we can perform on a piece of data, right? And there's a whole list of those, what we can do, but some of these common methods are turning all of a string uppercase or lowercase, or taking out a piece of information from a string, or splitting the string. In the example of Tom's cat, let's say we want to split it on the blank space. It would then be Tom's cat. It would be 2 different pieces of data. Okay. We can also add strings together, right? If I want to have all of your last names, all of your first names, I want to add them together. The N would be, a single piece of data that was first and last name together. Okay, kind of like how we did in Excel last semester. This is how we do this. We use methods by calling the piece of the data container or the string, and then adding the dot afterwards, and then the method. And I'll show an example of that here in a few minutes, okay? Numbers, all right? Numbers, we have integers and floats, right? Whole numbers without quotes. Floats are a number with a period representing a certain level of precision. Again, not quotes, right? So strings, quotations, numbers, no quotations. We can do any number of mathematical functions on these. Add, subtract, multiply, divide. We can do exponents, which I thought was a caret, but I guess in Python 3 it is now the star. We've switched from Python 2 to Python 3 recently, so some things are different, right? Calculating integers, here's an example. This is how you used to have to do it, but now you have to do it this way. Okay, so we'll go through some examples of that here in a moment. Most important thing that is probably maybe not the most difficult, but definitely one of the most critical components of this first lecture is the data container. Okay, a data container is a data structure that stores and organizes virtual objects, right? So a string is a virtual object, an integer is a virtual object. All virtual object is a self-contained entity that has data and procedures and how to manipulate it. We cannot do things to a string that we would do to an integer. We can't do things to a float that we would do to an integer or a string. Okay, they're all slightly different. Okay, and so the three big types of data containers that we'll talk about are variables, lists, and dictionaries. Okay, a variable is one simple piece of data. It could be a little bit more, but generally a piece of data, right? X is equal to 125, right? The variable is X, the data container is X, and it has a value of 125, right? We've taken 125 and we've put it into X, okay? Right? And so X is now contains data that relates to an integer. It follows integer rules, okay? Lists are multiple variables, right? It can be I can have a list of string values that are all of your names, right? I can have a list value that is integers, that is all your social security numbers, right? Dictionaries are a little different, a little trickier. Think about an actual dictionary, right? You have a reference, a key, right? A word, and you have a definition. The definition being something like, it describes what actually has information related to that reference or that key, right? So for example, if I had a dictionary that had, say, all of your names were keys, the dictionary, I could then put information related to you all into that key reference, right? So for myself, I would say, let's say I'm in the list 2. I could say I'm teacher. I have 0 grades and this, right? And the next person could be, somebody else, student, this grades, right? And so all of these pieces of data reference a specific key, in this case, a student. Okay. Oh, cool. I have some extra slides here. A variable. Every value is a Python object. Okay. This is object-based programming or object-oriented programming. So everything is an object. Okay. A variable is a label that refers to the Python object. You can change the value of a variable at any time, and this is going to be challenging, right? So making sure that you select words that are meaningful, right? So not using, say, x is equal to 12, and then later on, I'm going to use x as a variable name again. You want to keep track of the values, right? How you run your code also matters. Your code is, for the most part, and we'll get to examples of when it's not, linear, right? It starts at the first block and it goes to the bottom. So if you put in at the top x is equal to 12, and then later down you put x is equal to 13, if you run this line down here and then try to go back up without running 12, anything in between is going to reference x as 13. Okay, so how do you sequence your code matters. Can't start from the bottom and work your way up. It's got to go top to bottom. Okay, so we do variable names. We want to be meaningful. We can't use Python keywords. I've posted or I'm going to post a list of these keywords. Keywords include true or false, with. Generally speaking, Python will give you an error when that happens. Just make sure that you are not using that. You can use strings and underscores, right? You can use letters and numbers, underscores, everything to give your variables names. That's fine. They can include numbers. You can use underscores to separate them for reading purposes. Do not use spaces. Okay, so it should be all one word. So Professor Baxter teaches programming as one word, or Professor underscore Baxter underscore teaches underscore programming. Okay. All right, so that's the end of the code. Let's look at some examples of code for that. Okay, so let's do an example. Let's do an example of some code, and let's do giving a string. Let's do creating a data container called greeting. And in that, we're going to put a string value. We're going to say, hello, IA students. Okay. That is a string value. Okay, we've created value. We've created it is a string. The type of it is a string, right? We can say, actually, I don't know if this is going to work like this, but we can try it. Type. See, has no attribute type. And so this is what we talk about when we talk about the difference between functions and methods. I've set this up as a method. Okay, greeting dot type, and it's not a method, it is a function. So we can say print type greeting, and we'll talk about the differences later. And so we can see that it is a class string. Okay, all right, and we can do stuff with it too, right? We can say instead of so that we can say, let's say, hey, name is equal to Alice, and we could say full greeting is equal to, oh, I am still here, thank you. Full greeting is equal to greeting plus, let's put a space, plus name, and we'll do let's do this. Oh, and Alice, and then we can print full greeting. Okay. So what I've done is said, okay, create a new value. Okay, create a new data container that puts greeting, which is this up here, adds this string, and then adds this name, and then also adds an exclamation mark to make it fun. We could say, hello, IA students, and Alice. Alice. Anyway, string slicing, we can also cut things up. So we could say data science and spell science correctly, right? And we want to, let's say, print, instead of the whole thing, let's print out just the first word. Oh, it doesn't like that syntax. Oh, it's because I forgot to add in the actual data container. See, told you we're going to make mistakes. Okay, so what did I do? I said print this data container, but only give me points 0 through 3. So it said this is 0. The first number is always 0. First letter is always 0. First number is always 0. We always start at 0. So 0, 1, 2, and not 3. Okay? We're going to talk about this later, but when we do this is called indexing, the last number is not included. So I've asked it to print out 0 through 4, not inclusive of 4. And that gives me data. And then we can also use methods, right? And so methods include, let's say we want to make an uppercase, and we'll do uppercase greeting. We already have greeting up there. And this is equal to, we're going to say greeting, upper, and close it off. And then we're going to print uppercase greeting. Okay. Hello, IA students. Okay, so again, this is a method. A method is what we can apply to manipulate these different data containers. Okay, so those are that's working with strings a bit. We can also work with our integers, right? So we can say a is equal to 10, and B is equal to 3.5. Okay, so I've created two data containers. One includes a, where's my hashtag? There it is, an int type, and this one includes a float type. And then we could do things like this. We can do some results is equal to A plus B. We could do product result is equal to A divided by B. And we could do exponent result is equal to A to the power of B. And yeah, and then if I run this, what happens? I just get a check mark. It's done. So I've put all of the stuff exists now in these data containers, but I haven't told it to do anything. So the stuff exists there, but I haven't given instructions to what to do. So we're going to print results. We're going to print the product results. You can see that these things are popping up as I go. It's like especially helpful. So you don't have to type everything out. And then I can run that. And so we have 13.5 is the product. Sorry, the sum. Product is 2.8. And our exponent is over 3,000. Okay. There's some other things here we can do that are just integer related. We'll talk about that later. We can do other things like change our variable name or adjust things as well, or change our variable values. So let's say I say x is equal to 100, oops, and y is equal to 10. And let's say I want to say change my value. Let's say down here I'm like, actually, you know what? X is equal to 50. Say print x plus y. So let's say I run this. You'll notice I get two different results. Okay, this one is pulling on this. This is pulling on this set to 50. It's changed, right? Remember how I said it depends on the order, right? And so now this is different because I've reset the value of x to 50 rather than 100. So I've changed it. It will stay. If I keep doing stuff down here, it will never go back to 50 again or 100 again, just because now that I'm further down, it is stuck to the it's stuck to this number here. If I did something different here, it would change, but it would change anything between here and here. But I have to stick with in order. Okay, so this has been like the kind of high-level intro to some of these elements, just kind of getting you familiar with some of these things. We're going to practice on Wednesday and do some more work. Okay, all right. Thanks, everybody.